Welcome to this video. So in this lesson, we are going to look at questions on the exponential distribution. All right, so if you have a random variable x that follows an exponential distribution with the parameter lambda, okay, then the PDF is going to be given by, okay, the PDF of this distribution, f of x, will be given by lambda e to the power minus lambda x, okay, for all values x greater than or equal to what? To 0. So this here is our PDF under the exponential distribution. And then our parameter lambda will be equals to 1 over the mean. Okay, so very important information to keep. Our lambda will be equals to 1 over the mean or the average. And then our our PDF, will just be lambda e to the power minus lambda x, or x is greater than or equals to what? To 0. Okay. And then another important thing that you have to know under the exponential is the PDF. Okay. So the PDF under the exponential, which is the same as the probability as x is less than or equal to a small value of x, okay, is equals to 1 minus e to the power minus lambda x. Right, so we're going to be using this information to answer these questions. So the first one, they're saying the time in hours of a transistor last follows an exponential distribution with a mean of 100. So meaning the mean there is what? 100. Find the probability that a transistor lasts longer than 15 hours. So here we're finding the probability that x is greater than what? 15. Okay, so this one is the same as, by the complement rule, it's the same as 1 minus the probability that x is less than or equal to what? To 15. So this would be 1 minus it. Okay, so this part here defines the CDF, okay, of the exponential distribution, which is this guy here. So if you have x less than a certain value there, it's the same as 1 minus, okay, e to the power lambda, and then you put that value of x, which is 5, like this. Okay, so what is our lambda? So remember, our mean is 100. So it means lambda is equals to 1 over what? 100. So here, to be 1 minus 1 plus lambda, plus e, and then to the power minus lambda. So minus lambda now, minus 1 over 100, then multiply by 5. That's what we have. Okay, so that will be the probability that x is greater than what? 15 hours. So we see that this one and this one will cancel, so just remain with e to the power minus 5 over 100. Okay, so this is not hard. You just get your calculator and approximate it. Okay, so this is 15 actually. Why was I writing 5? So this is 15 because we are finding for 15 there. Right, so just get the calculator and punch in those values there. So it will be equals to e to the power minus 15 over 100. It's giving me approximately 0.8607. Okay, so that's the answer on A. Let's look at B. So B, they're saying find the probability that transistor, okay, lasts longer than 110. So this here is the same as 1 minus probability that x is less than or equal to 110, which is just 1 minus 1 minus, okay, I'm using this, the CDF, so it will be e to the power, the lambda is 1 over 100, and then the x is 110. So this is what I have. So this one and this one will go. I'll just remain with e to the power minus 110 over 100. So let's punch this into our calculators. All right, so it's giving me approximately 0.3329. So that's the probability that it will last lasts more than 110 hours. Okay, let's calculate C. So C, they are saying it will last longer than 110 hours, given that it lasts longer than 95. So that's the conditional probability. So we are finding probability that, okay, X lasts longer than 110, given that X lasts longer than what? 95. So if you want, you can move, you can use the memoryless property here, okay? Because this is just conditional. So by conditional probability, if A given B, this is the same as what? It's the same as probability of A intersection B divided by probability of what? B. So this will be the probability of X greater than 110 intersection X greater than what? 95 divided by the probability that X is greater than what? 95. So you can use the memoryless property. So meaning the memoryless property will forget that this was already elapsed. So it will just be probability of X greater than 110 divided by the probability that X is greater than what? 95. But if you don't want to use that, you can still find the intersection. So you just draw a line and then you put your 95 there, your 110 there. So remember, finding the probability that X is greater than 110, intersection X is greater than 95. So where is our X is greater than 95? It will be all this region here. And then X is greater than 110, it will be this region. So since we are finding for their intersection, then we'll just get this part here. Okay, that's what the memoryless property says, states. Okay, so it will forget about what has already passed to just focus on what is there. All right, so let's uh, let's find this probability now. Okay, so on top I have probability that X is greater than 10, 110 I mean, and then here I have the probability that X is greater than 95. All right, so probability is greater than 110. We found it on B. Okay, we found it to be 0.3329. And then probability that X is greater than 95, it will just be equals to E to the power 1 over 10 multiplied by 95. Okay, so how am I coming up with this? I first change it by complement rule, then I apply the CDF. Okay, I end up with this. So this is going to be equals to, okay, so E to the power 95 over minus 95 over 100, it's 0.8607. So that's the probability there. Okay, so to find this, we are dividing this probability with this probability. Okay, so let's find the final answer. Okay, so the probability that X is greater than 110, given that X is greater than 95, will be equals to, this probability is just 0.3329 divided by, okay, the probability that is greater than 95, it's 0.8607. Okay, so we divide. Okay, so I think I didn't get the correct answer during my calculate. So here, what am I supposed to get? Okay, let me just check. Okay, so if I have E to the power minus 95 divided by 100. Okay, so I don't get this one, so I'm getting 0.3867. Okay, so it's the one that I'll divide with there. So this here will be 0.3867. So when we divide this, what are we going to end up with? So 0.33 29 divided by 0.3867. I'm going to end up with 0.86 0, 1. Okay, so that would be the probability that it will last 110 hours given that it lasts 95 hours. All right, so next we look at a similar question on the distribution. So here they're saying the rainfall in Sulawesi follows an exponential distribution with mean. Okay, so the mean is equals to 15 per day. Find the probability that the rainfall will exceed, okay, will exceed 15 milliliters on a given day. So we're just finding the probability that X will exceed 15. Okay, so how can we find this probability here? Okay, remember we said the PDF is just going to be equals to the parameter e to the power minus parameter x, and then the CDF is equals to 1 minus e to the power minus lambda x. Okay, so here the mean is 15. So meaning the parameter is just 1 over what? 15. So probability that x is greater than 17 is the same as 1 minus probability that x is less than or equal to what? 17. So this will be equals to 1 minus, okay? So this one is just the CDF. So the CDF is given by that. So 1 minus e minus, so I put the parameter 1 over 15 multiplied by the x, which is what? 17 in this case. So what I have is 1 minus 1, that will cancel out. Then negative and this negative, I get e to the power minus 17 over what? 15. So let's calculate this on the calculator. Okay, so I have e to the power 17 divided by 15. Okay, so I'm finding 0.321 okay, 196. So that is the probability that the rainfall will exceed 17 milliliters on a given day. All right, awesome. Let's look at B. So B, what are they saying? So B, they are saying find the probability that in 4 out of the next 5 days, okay, in 4 out of the next 5 days, the rainfall will be less than the mean. Okay, so now this here, okay, is going to follow a different distribution, okay, because of the conditions that we've been given here. So it means the information on this B here, okay, we're going to say X on B here follows a binomial, okay, and that binomial, it will have how many trials? N is equals to 5, because they're saying in 4 out of 5 next days. Okay, so the number of trials is 5, and then the probability of success is equals to the probability that the rainfall is less than what? 15. So this is the distribution that we have now. Okay, because here they're saying find the probability that in 4 out of the next 5 days, the rainfall will be less than the mean, and the mean is 15. So rainfall should be less than the mean. That's my probability. And then the number of trials here will just be 5. So we want to find 4 out of 5. Okay, so we know that the probability that we're interested here is finding x is equals to what? 4. So 4 out of 5. But if x follows a binomial, okay, then the PDF changes. Okay, so the PDF of x will just be equals to n, and then x p, probability of success, to the power x, and then 1 minus p, which is the same as q, to the power n minus what? X. Okay, so I'm finding the probability of 4. So n, we said it's 5, so that would be 5 over 4. 4 out of 5. This is what we have here. Then the probability of success is the probability that this is less than 15. So how do we find this? We use the exponential distribution. So probability that x is less than 15 will just be equals to, okay, probability that x is equals to less than 15 just be equals to Right, so this here is just this CDF here. Remember, the CDF is equals to P, X is less than or equal to a certain value of X. Okay? Right, so this would be 1 minus E to the power, the parameter is 1 over 15 multiplied by what? The X, which is 15. So what I have there will just be 1 minus E to the power minus 1. Okay? So it will be 1 minus what is e to the power minus 1? E to the power minus 1 is about 0.3679. Okay, so this is the probability that xc is less than what? 15. So let's write it somewhere here. So probability that x is less than 15 is equals to 1 minus 0.3679. So this here is going to give me 0.6321. Okay, so that would be the probability of success. So wherever there's P, I'm putting that. So where there's P here, I'm putting this. So it would be 0.6321 to the power X, which is 4. And then 1 minus, okay, 1 minus P is going to give me what? It's going to give me 0.3679 to the power N, which is 5 minus X, which is 4. So this is the probability that we are looking for. So we can erase all these other stuffs now. Okay, so probability of 4 is equals to, so what is 5 combined 4? Okay, so 5 combined 4 is just 5 multiplied by this number to the power 4. Okay, so that number to the power 4, my calculator says 0.1595. Okay, multiplied by this one to just be 5 minus 1, which is 1. So it's just the same number. Okay, and then we go back to our calculator to calculate it. So this is going to be equals to, so 5 multiplied by this, I'm getting 0.2935. Okay, so counter check with your calculator as well. And that's all for this video. Thank you so much for watching.